Okay. Then, yeah, this is the notes. And let's see whether we can expect. Okay, okay. This one. Maybe the promo will go deep into the alkane here. Yeah. Okay. 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 This is alkane here. This is alkane. Then only one reaction. Only one reaction in here. Actually, we know we have cracking one. Yeah. But this one. This is free radical substitution. Yeah. So remember on the last lesson we have three. We have three species that can attack the organic substance: nucleophiles, electrophiles, and
free radicals.
Free radicals. Yeah. And the one that can attack alkanes is the free radicals. The nucleophile, they can't attack. Okay. First of all, how do you get the free radicals? There are many free radicals, but the most common one is this one. You have chlorine like this, yeah? And you have bonds between chlorine. Then you have ultraviolet. I think it's too small. You should draw bigger. We have CO2, yeah? We have CO2. Chlorine and chlorine. You have bonds between them. And you have ultraviolet light. And the light is a wave. But if you take physics, the last chapter of physics, they explain about this quantum physics. So light is also a particle. Then the particle, the name of the light particle is called photon. This photon spread out everywhere. Yeah. And if just nice, the photon pass through between the chlorine, they can break up the chlorine. Yeah. Why UV? Because UV is the correct size, so-called, yeah, the correct size that can break up chlorine and bromine. If it is not ultraviolet, if the frequency is too high, that means the size of the photon will be too big, then cannot go into cleavage between the two chlorine. If it is too small, then it's not strong enough, cannot break it up. So ultraviolet is because of the experiment. Yeah. Then the chlorine, remember, have 7. Then they will break up. And the way they break up, each of the chlorine bring their own electron in the middle there. Yeah. Which is this thing. Which is here. Yeah. The 2 electron, the bond will break up. Then each of them will have 7. Now, this chlorine atom here, is it positively charged or negatively charged or neutral?
Negative.
No, neutral.
Oh.
Because before it's neutral, when you break it up, nobody is taking extra electron. Understand? Chlorine have 17 proton and 17, so it's neutral. Both of them are neutral. Then both this neutral, that means they cannot attack electron-rich carbon. They cannot attack electron-poor carbon, but they're very reactive because you have this unpaired electron. So they're very reactive. So this chlorine atom by itself, which is unstable, then this thing you call it something Cl radical, and the symbol is Cl with dot like this to indicate that you have one electron there. Yeah. Yes. This process of breaking up the two chlorine into the Cl2 into chlorine atom, this process is called something. This process is called homolytic fission. Okay, and this is due to the UV light. You have another process called heterolytic fission, which is not for this reaction, but I explain. They break up, and the way they break up, one side take the electron in the bond. So they break up. This one will be, for a short while, it will be like this. Yeah. This one will be then will you have charge here? Yes. This one you call it Cl plus, and this is Cl minus. Okay. This Cl plus is a nucleophile or electrophile?
Nucleophile.
Oh, electrophile.
Oh.
Why we call it electrophile? Because it's positively charged. They like something who are negative, and electrons are negative. Yeah. So electrophile will attack carbon that are electron rich. Yeah. So this Cl minus, you call it nucleophile. So that's how you get this thing. So this process is called something where Cl2 turn into Cl plus and Cl minus. You call it heterolytic fission of chlorine. So this is the chlorine radical. Yeah. And they will attack. Now, the chlorine when the UV light, like you want to have the reaction, so you shoot UV light into chlorine. Will all the chlorine turn into radical? No, only small amount. Reason? Because the probability of the UV light hitting just exactly between the two atoms are quite low. So if you
Okay.
have, let's say 1 million, maybe only 100 or 200 break up. Yes. Okay, break up. So you have only small amount because it's difficult to get into small amount. And these radicals is created in your body also. If you walk under the sun, then you have, then if just nice the position of the UV light is hitting the place between the two carbon anywhere in your body, so it might break. Then you will produce the carbon radical. Yeah. Is it bad? Yeah, it's, in general it's bad. But is it dangerous? No, because only small amount. Unless you stay there for very long time, so it accumulated, so you have more radicals. Understand? Yeah. So yeah, try to avoid walking under the sun at noon because the UV light is too much. When is the best time for you to walk under the sun?
Evening.
No, 9 a.m. No, not
Oh.
evening. Evening you don't. 9 a.m.
Okay.
9 a.m. because we still need UV light to convert to produce vitamin D. Yeah. So like that. So that's it. Yeah. Now this is the reaction, the free radical substitution. Yeah. The name of the reaction is free radical substitution. People call it FRS. Yeah. Okay. The first step. Yeah. Cl2. Oh, not the first step. The overall reaction. Yeah. We call it overall reaction. Overall reaction. Cl2, let's say with ethane, yeah, C2H6. Can guess how it will produce? Write down and give the name. Okay. Usually CH, then anything is you put behind.
Oh, okay.
Yeah, C2H5Cl. Yeah. Now this is okay. This is the reaction mechanism. Yeah. Okay. Very good. Write down the name of the part. Chloroethane. Yeah, very good. Yeah, something is wrong in your equation. What is wrong there? The H not balanced.
Oh.
What is it?
Is it HCl?
Yeah, HCl. Yeah.
Oh.
So that's why it's substitution. Substitution means you're the organic compound. I give you Cl, but I take something from you. In that case, I take H. So that's the meaning. Yeah. So as the organic compound, you're gaining Cl, but losing H. So that's why it's called substitution. Okay. This one is the reaction. Reaction mechanism. First step here. Cl2 plus. Okay, I take something. Suddenly have something here. First of all, yeah, initiation. Initiation means you're producing the radical. Yeah. Then the Cl radical react with C2H6. Then you produce C2H5 radical. And in the process is removing Cl. Yeah. And C2H5 radical, if you are asked to draw, try draw. Yeah, draw the C2H5 radical. The structure, I mean, yeah.
Is that it?
Yeah, then you mark the extra electron here.
Oh, okay.
Yes.
Okay.
That is 2A. Then 2B, yeah, is this C2H5 radical plus Cl2 turn into Cl radical plus C2H5Cl. Yes, you understand until here?
But why must you add back Cl2 again?
It's not me.
Oh.
It's the radical. The radical is attacking people. Yeah. The radicals means they like to attack people. In this case, they're attacking Cl2.
Okay.
They're dangerous molecule. Yeah, they're radicals, right? So then they attack, and in the process, okay. So this is the this process is called propagation. Propagation means you lose the radical, but you gain also a radical. The radicals spread out. The radicals are the one that are very reactive. They're the one who drive out the reaction. Yeah. Now, back to this initiation. If you have 1 million Cl2 and you shoot UV light, how many Cl radical are you going to produce?
2 million.
2 million molecules. No. I mentioned.
Oh.
The photon are, it must be some lucky proton who can get inside in between the two Cl. So very little. Right? The radicals are not so many, just small number. So if you have 1 million Cl2, you might end up with only 200 Cl radicals. How about the other 999,900 Cl2 molecules? They are not affected. They stay as usual. So this reaction for 2A here is only for, okay, so this is 1 million. This is 200. Only 200 molecule. This 1 million turn into 999,900. Agree?
Mm-hmm.
Because you decrease by 100. Yeah. So this is 200 here. React with 200. You produce 200 C2H5 and you produce 200 HCl. And this 200 C2H5 will react with 200 Cl2 and it will produce 200 Cl radical and it will produce 200 C2H5Cl. Does it mean that the chloroethane, you call it chloroethane, right? Yeah. Out of that 1 million Cl2, only 200 produce chloroethane? Yes or no?
Yeah.
No.
Oh.
Because this propagation repeat itself again and again and again. Because this Cl2 radical, that 200 Cl2 radical that is already produced, will have reaction to A again. Will attack another 200 C2H6. Correct? Which will produce 200 HCl, and you have C2H5 radical, which can be used for reactions. So it will go. It will keep going on. You have reaction 1. After that, you have reaction to A. Then after that to B. Then back to A again. Then back to B. So reaction to A and to B keep happening. Yeah. Until what happens? Until you run out of C2H6.
Oh.
And until you run out of Cl2 also. Depends on who's the limiting reagent. So you will end up with almost 1 million chloroethene. This is the product, right? This is almost 1 million chloroethene and almost 1 million, because initially this is 1 million. Almost 1 million. But it's happening 200 at a time in this example.
Okay.
Correct?
Yeah.
Because you produce the radical. Yeah. Why I say almost? Why I didn't say 2 million, exactly 2 million. Why? Because at the end of reaction to A and to B, you still have 200 Cl atom and 200 C2H5. Yes. So you have 1 million Cl2 and 1 million ethane. 1 million Cl2, 1 million ethane. You react them together using this process. Then you will get almost 1 million HCl and almost 1 million chloroethane. Yeah.
Okay.
So you have that extra. What will happen to that extra Cl radical and C2H5 radical? They will have reaction number 3. Okay, this reaction number 3, we call it termination. Termination means the radicals and radicals, they will react among themselves. Yeah, that means the Cl radical plus Cl radical, then they turn back into Cl2. CB, C2H5 radical plus Cl radical. So radical and radical, they react together. Then they will form C2H5 Cl. Yeah, 3C here. This is this thing. C2H5 plus C2H5 radical. It will turn into C4H10. Yes.
Okay.
So you get almost 1 million HCl and almost 1 million chloroethane. You get very little, small amount. Is it going to be 100? Less than 100? Yeah. Yeah. This one also less than 100, but it's the same as this one. So it's you mix up, so you don't know how much. This one is very little, extremely little, and it's difficult for you to measure. But you can find it. You can prove that it exists. So this one, this C4H10, which is butane here, you say that is produced in trace amount. Yeah. Yes. Answer. And they will ask in multiple choice. Usually multiple choice. They will ask what substance will be produced in small amount when you are reacting this thing. Yes. Okay. Yeah. So this is the overall reaction here. Overall reaction is not 100% true, but it's almost true because the ratio is 1, 1, 1, 1, right? Which is actually not true because this one is decreased by a little bit because you have some, yeah. This one also decreased by a little bit because you produce something else, yeah. Okay. Now, now the combination of question can be many things. Can be they can make a complicated question for this free radical substitution. For example, if you have propane, yeah, propane, if the reaction is propane plus Cl2, you feel like, yeah, give me the overall reaction. Propane is C3H8, yeah. Okay, then write down the mechanism also. One A. Yeah. Then 1, 2A, 2B, then 3A, 3B, 3C. Yeah.
Okay.
Yeah, good. Very good. Yeah, good. Okay, good. Okay, first of all, this one are the details, right? Very detailed question and very confusing. This one is called chloropropene. How many possible chloropropene are you going to produce? How many? Are you how many isomers? Or I ask how many isomers of chloropropene?
2.
Try draw structure of chloropropene, the 2. And if possible, you name it. Yeah, you give name to it.
Okay.
Okay, good. Okay. So these are the 2 isomers. Which one do the reaction produce? Is it one of them or both of them?
Both.
Both, correct? Why?
Uh,
How do you know? How can you guess that way? Because Cl radical will attack randomly. They are reactive.
oh,
So if they have a chance to hit anywhere, then so you produce both. Yeah. Now they produce both is correct. Which one will they produce more? Okay. Okay. Which one? Can you guess?
1 chloropropene.
Will produce more. Correct. Wow, good.
Oh,
Why?
I don't
Don't know. Tikam. Okay. Okay, this is the explanation, but this is correct. It's correct. The explanation is like this. You have a propane like this, and the chlorine can attack any of the hydrogen here. Yeah. Okay. If they attack the blue hydrogen, they will become 1 chloropropane. If they attack the yellow hydrogen, they will get 2 chloropropane. So why you produce more 1 chloropropane than 2 chloropropane?
higher chance.
Higher chance, good, because you have more.
Blue.
The higher the probability of attacking the blue hydrogen. Yeah, and you have 6. The yellow hydrogen is only 2. So the ratio is roughly 3:1. In fact, it's the probability is more than 3:1. Can be more the ratio between the 1 chloropropane and is more than 3:1. Reason? Very simple. Because these things are at the end here. So you have this chlorine are more spread out. So you have more angle of attack. Yeah, if anywhere you attack anywhere from here, then you react with the blue hydrogen. Only if you attack here, that means this area here, the red area and the green area, the red area is very small compared to the green one. Yeah. Okay. Yeah. So it's even more than that. Okay, that's one type of question that they can ask. Yeah. Another thing, you're producing C6H14. What's the name?
Hexane.
Hexane. Okay. Draw draw the possible isomers of hexane. Yeah. And then we try. Yeah. Okay, try. I'll check something. Try all the possible isomer of hexane. Let me check. Okay. How many? Where do you draw it? On paper? Or this
Oh.
year? Okay. Okay.
This
No.
side.
Okay. Hexane. Oh, okay. Good. Okay, hexane. Yeah, right. There's number 1, 2-methyl, 3-methyl, 2,2-dimethylbutane, and 2,3-dimethylbutane. Very good. Yeah. Yeah, right. Any chiral carbon? No?
No. Eh?
Yeah?
No.
Yeah. you have actually this thing. No, you're not. Yeah, you don't have. Sorry. Yeah. Right. So yeah, 5. Which of these isomer is produced by this termination process in this example here? Is it all, or some of them, or only one of them?
All?
All? No, not all. The one that can be produced from that reaction is this one. This one. And this one. Yeah? 3 and 4 cannot. Reason. The reason why? Because the radical that you have is only two type. C3H7 like this, right?
Yeah.
C3H7. Okay. There are only two possible radical. Either you put at the end here, or here. Correct. Yeah. Any other possibility?
No.
No. This one is radical number 1. This is radical number 2. Yeah. Is it possible that R1 react with another R1?
Yes.
What will you get? Correct?
Yeah.
That means this thing, these two, from this one here. Agree? And what is the product? What's the name of the product?
Same.
Exchange. Yeah. Fine. Draw the other two. Yeah. Is it? Yeah. Which one? Yeah. What will you get? Yeah. Good. And give me the name.
Oh.
Which is this thing, right? Like that. Yeah, correct. Yeah. Yes, easy. So this is the question that they used to ask students, right? They ask the ratio between the two main products. Try one more. Uh, Free radical substitution of butane. Yeah, write down the reaction mechanism and give the product. Yeah, and then the two possible product. Yeah, and possible trace amount, possible substance produced in trace amount. Yeah.
Is it still chlorine?
Bromine, let's say bromine.
Oh,
Yeah.
okay.
Okay. Yeah. Yeah, good. And yeah, good, good, good. And draw the possible product.
Oh.
Possible product for here. Yeah, two only. Yeah, and give the name. And which one will you produce more?
Um, one bromo butane.
Yeah, good. The ratio is roughly how much? The ratio?
Uh, 2 to 3.
2 to 3. Yeah, okay. And try give me all the possible isomers of that. Then after that, you say which one is
But I thought I already drew the promo gifting.
Oh, sorry. This thing.
Oh,
The one that you purchase in trace amount.
okay.
This is very little, right? Yeah. Where do you draw it? Octane. Okay. Oh, then you have a lot. But it's okay because you draw skeletal hollow, right?
What is 7 for?
Captain.
Oh yeah, okay.
Okay. Yeah. Yeah. You very good. You do it systematically. 3, 4, 5. Yeah. Wow. Wow. Good. 6, 7. Okay. 6, 7. Two, 3, 2, 4. How about 2, 5 here?
Reactive 5 is at the bottom.
Yeah, it's possible, right? Or
Yeah.
2, 5. Okay. 8. 9. 10. Okay. Then you have so many, right? Later you can continue. But which one? How many will? Which one will be produced here?
Uh,
Okay, try and draw the radicals. How many
oh,
possible radicals are there? And yeah, is for yeah for hydrogen, right?
mm,
Yeah, good. Then this is the octane, right? How many you produce? 3, right?
yeah.
Ah. Ah, like that.
I don't know.
This thing also wrong.
Oh,
Oh, you number it. 1, 2, 3, 4, 5, 6, 7, 8. So number 4 is connected to 6. 1, 2, 3, 4. Oh, this is correct. 5, 6, 7, 8. Yeah, correct. 5, 6, 7, 8. Yeah, correct. 4 to 6. 1, 2, 3, 4. Yeah. How come you get like this? Yeah.
I don't know how.
Oh, it's correct. 1, 2, 3, 4. 5, 6, 7, 8. Oh, I think it's wrong. Number 2 connect with number 6. Yeah. 1, 2, 3. No, it's wrong. You don't understand.
No.
We just do. Okay. We just do here. Okay. And this is 1, 2, 3, 4, 5, 6, 7, 8. Connect with this here. Yeah.
Oh,
5, 6, 7, 8. Okay.
okay.
If you want to straighten out, then if you want to straighten out, that means this thing, this is the main structure, right? This is enormous. So this one. Wait. Okay. 4, 3, 2. Okay. 4, 3, 2, 6, 7, 8. Yeah. Like that. Number 2 connect with 1, 6 with 5. Like this. Yeah. Can?
So either way also can.
Either way also can.
Okay.
Because this is still same connection. 4, 3, 2, 6, 7. Yeah.
Okay.
Okay. We do exercise. So I already put here